Good afternoon, everybody. I'm aware that this is the mid-afternoon session, so I'm going to try and wake you all up a bit. Can I please have a show of hands who here has an electric car? Yes, very nice, thank you, gentlemen. And can I just check with you guys who has a Tesla? Oh, hard luck, sorry guys. Yeah, rough times. No, good. Myself and my partner have an Ioniq 5, which we quite like, which inspired this presentation. So what are we going to do here? So look, we are going to build an electric vehicle charging map. We're going to do some routing, going to do some calculations, going to be very good. I am not going to stand here and say, throw your Google Maps out the window and write your own routing system and use it everywhere you go and build a server farm at home. No, this is a use case that we're going to use to demonstrate some of the really cool features and functionality of PostGIS. And everything we're going to use today, we're going to build a map server, we're going to run a bunch of data. This is all open source, completely open source technology, very accessible, all free to use, and I'm running this on my own kit at home. So totally good to go. So this is these are the topics we're going to cover today. I'll just skip over this a little bit because nobody wants to read a slide. Few introductions to a couple of things, starting with me. We'll get the boring stuff out of the way. So I work for EDB. I'm a solutions engineer, but really I just do a bit of anything data related. Used to be a data wrangler a long time ago, systems analyst, data architect, you name it, I've probably done it. And now I'm working here at EDB. So who's EDB? Very, very quickly get this out of the way. So EDB are the biggest contributors to Postgres. So we write over 30% of the code of Postgres every year, and we provide support and solutions for Postgres and the ecosystem around it. So normally when I do this talk, I do have to, depending on the audience, I have to give a little bit of information about Postgres. Given that I'm talking to a development audience today, I'm going to guess that pretty much everybody here is fairly familiar with Postgres. The one thing I'm going to point out today out of my fabulous slide of all the advantages of Postgres is going to be the extensibility and the flexibility of Postgres as a server. So the reason PostGIS was built on top of Postgres is because you've got amazing things like user-defined data types, user-defined indexes, and you've got a lot of flexibility in terms of building, your own plugins and systems for Postgres. That's why the ecosystem is so massive, and that's why PostGIS 20-odd years ago was built on top of Postgres. So a little bit about PostGIS or PostGIS, however you like to say it. It is the spatial data extension for Postgres, completely open source as well, which I'll note the licensing costs for which are far lower than the likes of ArcGIS, Oracle Spatial, Esri. You get the picture. We'll carry on with that. So as I said, it is over 20 years old now, and we're going to use it today to build our own map server. So it's worth bearing in mind. All the data I'm going to show you guys today, all of them, the map, the actual map that you see, it's not a layer, it's not an imposition, it's not a sort of background drop. It's actually the map that's stored in PostGIS as Postgres data. So yeah, 100% open source. The other thing I want to say is just a little bit about the mapping data itself. So the mapping data is all open source as well. This is all taken from OpenStreetMap. So OpenStreetMap has data files available in various different formats that you can import straight into your Postgres database or other data sources. All of that is very, very widely available. In terms of there's a lot of people out there using this data. So some of the users of OpenStreetMap, people like Facebook, people like Apple, interestingly Tesla as well on their screens. They use that in the cars as well. That's the base of their map. Don't know if you've ever played Pokemon Go or any of the other Niantic games, the augmented reality games. They all use OpenStreetMap as well. So these are just a couple points to bear in mind, just as we're kind of going through the spatial data concepts. Just bear in mind concepts like nodes, which are basically points on a map, concepts like ways, which are linking one point to another. And when this data is stored in OpenStreetMap, all the metadata is stored in relations and tags. So that's all you need to know for now. So, cracking on through. So how do we build the initial map server that we're going to start doing our calculations on? So again, and I know I'm going to say this for the 4th, 5th, 6th, 7th time now, this is all open source. So what we're doing is we're building our map server using Postgres with the PostGIS extension. Then what we're going to do is we're going to import the OSM, the OpenStreetMap data, straight into Postgres. So you can do that with a tool called OSM to pgSQL. That is all completely automated, that process. It takes the data file and builds the entire mapping data set in PostGIS, which you can then use for queries. In order to get that onto a web server so that we can have a look at that through our web page and do that, we're using Apache, or Apache 2, I should say, and we've got a render-D set up as well, which is going to render the map data onto the browser so you can actually see the map. Last thing to point out is we're also using Leaflet. So Leaflet is a fantastic JavaScript-based layer that we're going to put on top of our map. We're going to be using a fair bit of GeoJSON today because that's how we import our spatial data into the Leaflet layer so we can show that on the map. So, few little things. So I have screenshots in here because now we all do a prayer now. We all pray to the demo gods that this is going to work this time because it didn't last time. Let's have a quick flip over, guys. Come on, machine. Let's try that again. Okay, this is our map server. Let's just refresh that. Okay, you can see this is live. All right, cool. So let's zoom in. Bear in mind, all of this data is all running, like I said, completely out of Postgres. So this is just rendering all of that data, looking around the northern beaches now. I should tell you guys, I used to live in the northern beaches, which is why I'm using this for my data set. Anyway, this is my map, as I said, all in PostGIS. So what we're going to do now, we're going to put a simple marker on the map for home. So let's go over to our code. So this is very, very basic, very simple. This is just our HTML code that we've embedded that JavaScript layer through Leaflet in. So let's just put a quick marker on the map here so you can see it's just very basic JavaScript. So let's save that. Let's load the map again. All right, so you can see now we've got a marker on the map for home. So this is important because home is where our car is that we're going to need to charge. So that's our starting point, and that's where we're going to go from. So where are we going to go now? So we're going to need to import the charging station data into Postgres. So what I've done is I've gone to Transport for New South Wales Open Data Store. Yes, very fantastic. Very, very good open data source. We like that. So they actually have electric vehicle charging data in their store, which was great because I thought I was going to have to do it manually, so I was quite happy with that. So basically all it is, comes as a CSV file, it's got some coordinates in there for each of the stations, tells you the provider, so I was like, fantastic, get that straight into PostGIS. So a couple interesting things to note, or important things to note about spatial data. Coordinates by themselves do not constitute spatial data. Now, this is because, and I'm not going to bore you too much with this, this is because depending on whether you're looking at a sort of Euclidean model of the Earth, so you've got that sort of flat, sort of oblong type shape that you see maps projected to, or whether you're looking at a spherical model of the Earth, coordinates actually have slightly different positioning in terms of how you do calculations and analytics on them. So when you import spatial data into something like PostGIS, you have to use a specific spatial reference system. And as long as you use the same one for all of your data, all of your calculations will be super easy, barely an inconvenience. So we're going to put our data into Postgres. So this is, I'm not going to run the actual database code live because that is incredibly boring. But this is the data as we've put it into Postgres. So you can see the code I've got there is basically just transforming the coordinate data into that spatial reference data. So you can see when I've done the select underneath here, that's the spatial data type that you can see in the geom column there. So all of my charging station data is now loaded into PostGIS. So how are we going to get that charging station data on the map so we can see it? So if you think about it, you're going to get your map open. You want to see that bit that you've got open on your map. You want to see the charging stations in that part. So what do we got here? We've got a polygon. We're going to give the code the polygon, and we're going to say, can you show me which of the points are within that polygon? So that's pretty simple. Not. No, it's all right. It's not that bad. This is actually a giant stored procedure code which takes my polygon and then it brings me back the spatial points that are actually within that polygon so I can represent them on the page. Now, the important thing to note here is that when I'm exporting this data, I'm exporting it as GeoJSON. So PostGIS has absolutely tons of GeoJSON functions. It's really, really useful. The translation to GeoJSON is obviously one of the most useful. You won't be surprised to hear. This is my procedure call here. You can see I'm just giving those coordinates, and I'm going to ask it to give me the charging station data back. So this is an excerpt of the start of the data that it gives me. You can see that's just really, really bog standard, very, very normal GeoJSON data, very pedestrian. And if we have a look over here, so let's go back in. If anyone gives me grief about running as root, we can have a discussion outside. It's Ubuntu, I'm so sorry. Okay, so let's scroll down here a little bit. So you can see that I have put sorry, it's going a little bit quickly, but I've put my GeoJSON data into my leaflet layer. So this is all those charging stations that I mentioned. We've got those in there. So, do you know what? Sorry, guys, I just have to get rid of the comment because that's what I'm going to do here. Okay, let's go down. That's my GeoJSON data, and we're just going to get rid of that as well. Save that. Okay, fantastic. So let's go back to our map. Fantastic. So I've just reloaded that map, and you can now see these points here are all charging stations. Fantastic. They're all on the map. Thank God it worked this time. Seriously, my VPN conked out last time when I was like, oh my God. Okay, cool. So that GeoJSON data's on the map. We can see the charging stations. So the other things we're going to want to do, because it's a charging station, and we're like, okay, let's say we've got about 60 kilometers left in our electric vehicle charging tank. We've got no solar power because the weather is rubbish. It's Sydney, right? So we always say, damn, we're going to have to get to a charging station. Which charging stations are within 60 kilometers of our car? So you think, oh, I'm going to have to write some kind of super complex query for that, right? It's like, no, super easy. So PostGIS just has functions. So this one is the dwithin function. And all we have to do is pass it the coordinates of the point that we want to measure around, pass it the distance, they measure in meters, so that's why it says 60,000 there, and say, give me all of the points that are within 60 kilometers of my starting point. Super easy. It's now given me a bunch of stations. So as with before, we can convert that to GeoJSON. We can put that onto the map. Don't need to do that for this one because we've already done that bit. This is an example of another query. If you wanted to know, for example, what are the nearest ones? What is the distance to travel? Again, this is a very, very, very similar query. We're again using the distance function. This time, we've just got a little bit more information in there in terms of we want to bring back the actual distance calculation between the points as well. So you can see we've got a distance function being calculated in there too. Super easy, all native to PostGIS, all available, like barely an inconvenience. So what is the other thing that we want to be able to do with our mapping data? So what is the use of mapping data if you don't have a way of getting a route from one place to another? So I should have said this at the start of the presentation. I appreciate there are probably people here who've done GIS before, probably very familiar with a lot of the stuff I've talked about and probably falling asleep right about now. I do apologize. I hope that the pgRouting stuff is going to be slightly more interesting. pgRouting is another, wait for it, open source extension to Postgres. Hooray, fantastic. So pgRouting, widely available. What it does is you can pass pgRouting mapping data and it will enable a network topology on top of your data. So this all sounds terribly fancy, but yeah, I don't do fancy, so I'm just going to give you the basics. What I mean by that is it takes all of your map data and it draws a nodes and edges construct on top of it. So each time you have a point, you've got a road that goes to another point, a road that goes to another point. For your entire map, what pgRouting is going to do is take that map data and create that nodes and edges map on top of it. So once it's got that, it can start to do calculations. So we're all familiar with the traveling salesman problem, right? I'm guessing computer scientists in the room are like, yes, traveling salesman, very, very good. So problems like that you can solve with pgRouting. So pgRouting has various algorithms written into it that you can sort of cost-based or function-based or time-based, or there's tons of different options to be able to calculate the best route from one place to another. So let's go and have a look. We're using Dijkstra's algorithm because it's the most common one and also the one I know the best. So setting up pgRouting to work with your OSM data. So I just talked about this a little bit. In terms of actually doing that bit where you create the network topology, again, this is super easy. There's a tool called OSM to pgRouting. Run that with your mapping data file. It creates all of this for you right there in PostGIS. I couldn't even believe this when I did this for the first time. I was like, I don't have to do any work. This is fantastic. So let's have a look at what that data looks like. So this is a table straight from my PostGIS database. And this is an example of a record from the vertices table, or the ways table, they call it. So you can see it's got data in there. It's got source, it's got target, it's got the points, the points data for your first node and your second node. And then it's got calculations, cost data, distance data, and so on that's related from traveling from that one point to another. So what this is representing is effectively, if we go down the road, we start at the beginning of the road, go to the end of the road, that's what this is representing and all the cost and distance around that. It's done this for every single possible little part of the route in my entire map of Sydney and New South Wales. So this is very, very cool. It didn't take very long either. I was very surprised. I did have a few calls going though, so. Okay, so what are we gonna do here? So getting a route to our nearest charging station and representing it on the map. So what do we need? We need the coordinates for our home base, which is our home where our poor electric car is going, oh, I've only got 60 kilometers left. And we need our target, which is gonna be our nearest electric charging station that we did before with our calculations. So that's fantastic. So what we're going to do, this is the pgr Dijkstra function from PostGIS. And I know you must be bored to tears of me saying this by now, but again, this is just so incredibly easy. So all I've had to do with this algorithm is I've given it the start point and I've given it the target point, and I've just specified a few of the available columns there for it to give me the data back. So what this is going to do, it's going to take those two, the start point and the end point, and it's going to give me a map of the best route to that destination. So the way it's going to spit that out, the data, what that's going to look like is spatial data, because again, it's in PostGIS. So we've got line string data in there at this point, which is representing a sequence of all of those different parts of the route all the way to the target station. So in order to get that onto our map, what are we going to do? Yes, GeoJSON again, fantastic. So we're going to call that PostGIS transform function again for selecting as GeoJSON, and we're going to output that to a file. Pretty simple. So we have, you can see this is an excerpt from the GeoJSON data that we created from the line string data. And let's just go over to our file again. Again, no calling the out for using root. Let's go down, function. Oh, GeoJSON data's long, isn't it? All right, so you can see here, this is all of that line string data that I've put into my map now. So let's just clear that out so that we can see this on the map. Fair few in here. I should say that there was 183 different edges on this map, on this route. This query took less than a second to run, which I just think is just really, really decent, given the fact that, again, this is all open source software, by the way. So let's save that. Let's go back in. We're going to load this on the map now. Oh. Yep, there we go. We can see we have got a route. Fantastic. So that's just loaded directly from my JavaScript data there. Oh, sorry, excuse me, guys. Just scared the crap out of myself. Ooh, that was fun. That was fun. Thank you for the sympathy. Alrighty, so we've got our mapping data here. One thing I should say about this, and this is a demonstration, so I'm not too concerned about this. You might notice if you zoom in far enough that we're actually going to drive our car through a park here, which is possibly not going to work that well. Having said this, this is all accurate routing. They're all walking paths. For the purpose of simplicity, I haven't specified where I'm going, so that I'm driving a car, because there are other elements that you have to put into that. So it'll do walking, it'll do cycling, it'll do driving, it'll do public transport if you've got the data that you can import. But yeah, this time we're going to drive our car through a park. So what are you going to do? So that's our routing. Yeah, so look, I just wanted to touch on another couple things before we finish up here. Just in terms of, because I do like to finish by talking about things that you can do in real life with PostGIS, because I know you're not going to go and build a charging map, this is just an example. But things like, so PostGIS is really, really good at integrating with other systems that require mapping functionality. So there's full support for KML, there's full support for MVT. And what that does is it means that you don't have to have a translation layer between the application and your database, so you're massively simplifying your stack. You guys saw today how good well, I hope you saw how good the GeoJSON support is. So tons of functions for that, really, really easy to run. Get that straight in your JavaScript layer and off you go. There's full support for 3D types as well, which is very good. Full support for 4D data types. I thought that was quite funny when I first heard it. It's not referring to a temporal dimension. It's referring to, for example, you might want sort of different calculations based on the type of land that you're on, or sort of things that quite often involve with mining and that sort of stuff. Other things, you can translate between using vectors and using rasters, which if you're familiar with that which is a very, very useful functionality to have. And it's also incredibly quick. So I should say that data that I imported into PostGIS, it didn't, OSM to PGSQL doesn't just pull all the data in. It also writes all the indexes for you as well. Which is fantastic. And the spatial indexing with Postgres is really, really good. So it's based on bounding boxes and arteries, and obviously the further you go down the artery, the smaller the bounding box gets. And they're actually self-balancing. So they're self-tuning in that respect, which is very, very good. And the one thing I'm going to repeat, and I'm going to repeat it again and again and again because I just think it's so fantastic, this is fully backed by Postgres. It is completely 100% open source technology. And compared to like I say, to the licensing costs that you'll pay for commercial spatial software, what this can do is just absolutely fantastic. So yeah, that's pretty much all I wanted to cover today. And there's my details if you ever just want a natter about Postgres. I'm always available. So thank you very much.